Yes, children, good morning. My name is Ram Babu. I'm in chemistry teacher. Today, we are going to learn one topic in chemistry, which is very important for SSC exams. From this chapter, definitely one question. Every year, one question will come for 4 marks. Such a very important topics about we are going to learn today. Okay. Next example, children. First one, just now we have completed that formation of ionic bond in sodium chloride. Okay, now second examples we are going to take, children. That one is second one. Okay, formation of magnesium chloride. Formation of magnesium chloride. Okay, well, children, magnesium also again, and S block element in metal, and chlorine also again, and P block element in non-metal. Okay, then ionic bond means in chemical bond two type of bonds, ionic bond, covalent bond, coordinated covalent bond also, but which is even given in textbook, two types of bonds only. Okay, only we are learning about ionic bonds. First one we have completed in formation of sodium chloride. And second one is the formation of magnesium chloride. Magnesium is a S block element in metal. Chlorine is P block element in non-metal. Okay, well, children, magnesium atomic number is 12. Magnesium atomic number is 12. Okay, start write electronic configuration, children. Okay, 1s2 and 2s2 and 2p6 and 3s2. One check it, children. What type of electronic configuration will come? Magnesium atomic number 12. The electronic configuration 1s2 and 2s2 and 2p6 and 3s2. Take it count, children. Only charge up values only we have to take it that atomic number. Okay, 2 plus 4, 4 plus 2 6, 10, 10 plus 2 12, which is a magnesium atomic number. This is the electronic configuration. Okay, children, magnesium should get stability means here outermost valence shell which one, children? Not 2p6 and 3s2 and 2s2 2p6 6 plus 2 8 is there here, and which is the, children? Valence shell here in 3s2. This one is the valence shell. Inside how many electrons are there, children? 2 electrons are. Those we will call it like as a valence electron. In magnesium, children, 2 valence electron is there, children. If should get stability means more 7 electrons, 6 electrons required. Okay, it should get stability means more 6 electrons should required. That means 2 losing easy 6 gaining easy Once imagine, children, and 2 losing only easy Anyhow, magnesium is metal, electropositivity, donating nature will be there. Can lose of electrons will be in metal side. Okay, 2 lose electrons from magnesium side. Then who will take, children? Chlorine. 2 chlorines are there, well. Chlorine atomic number means what, children? Chlorine atomic number is 17. Okay, so I'm starting to write, children, again electronic configuration 1s2 and 2s2 and 2p6 and 3s2 and 3p5. One take it count, children. 2 plus 4, 4 plus 2 6, 10, 10 plus 2 to 12, 12 plus 2 5, 17. Okay, then valence orbital, children, 3s2 3p5. Valence orbital 3s2 3p5. Then valence electron, how many, children? 5 plus 2, 7 electrons are there. From magnesium side 2 electrons are there. From chlorine side 7 electrons are there. But here 2 chlorines are there. Twice we have to take chlorine, Twice we have to take, Then chlorine is again 17. Again we have to take 1s2 and 2s2 and 2p6 and 3s2 and 3p5. Same here also, valence orbital 5 plus 2, 3s2 3p5, valence electrons again 7. Okay, in each chlorine side 7 are there, children. Here 7, here 7. If it get 1 electron, it will get stable. It will get 1 electron, it will get stable. Okay, 2 electrons required from chlorine side. Okay, from where we'll take 2 electrons from here, children? Non-metals means P block elements acceptor. Means we'll take electrons from metal side. Okay, from metal side, which one, children? Magnesium, 2 electrons are there. In each electrons, no, and here 2 electrons are no, one will come and join here, no, 8 will become, again no, one more will come and join here, one, total 8, and 6, 7 plus 1, 8, 7 plus 1, 8, like no, 7 plus 1, 8, 8 here, 7 plus 1, 8, then, so magnesium chloride is a stable compound. Okay, na? In this way, children, formation of ionic bond will be. In this way, formation of ionic bond will be. Okay, and first one, children, formation of sodium chloride we have seen, and second one, formation of magnesium chloride we have seen. Okay, now, like this, children, changing of electron, changing of ions, no, will form a new substance, will form a new compounds. Changing of ions means what, children? Magnesium having plus 2 electrons. Chlorine minus 2 electrons less are there. Okay, now from magnesium 2 will come and will join here minus 2. Once check it, children, how it will be there. And here once I am writing here magnesium plus 2 electrons and chlorine minus 2 will be there. The same number will come here. For example, no, I think here 3 electrons losing, here 2 will not take, like, okay, na? How many are losing here, those many will take here. Okay, na? 2 electrons losing here, 2 electrons will take from non-metal side. Okay, this is the formation of magnesium chloride, children. Okay, na? In ionic bond, children, 2 examples we have seen. What those are? Formation of sodium chloride, formation of magnesium chloride. Okay, na? And next, children, one more examples we will see. Okay, third examples we are going to take, children. The example is, which one that? Formation of magnesium oxide. Formation of magnesium oxide. One check it, children. Magnesium is, as of you know, magnesium is atomic number 12. The electronic configuration is 1s2 and 2s2 and 2p6 and 3s2. Yes, 1s2, 2s2, 2p6 and 3s2 is a magnesium atomic element configuration. Next, come to the, children, magnesium oxide, no, and magnesium is a plus 2 electron having, minus oxygen, no, minus 2 electrons will be there. Okay, now the magnesium 2 electrons can lose, oxygen, no, 2 electrons can take. How we will see? Okay, now then valence shell is 3s2, children, 1 orbital, that electron, children, 2 electrons. Okay, come to the oxygen now. Oxygen is, children, okay, now oxygen atomic number is how much, children? Atomic number is 8, no, and 1s2 and 2s2 and 2p4. Yes, 2p4 and 4 plus 2 6, 6 plus 2 8. This is the oxygen atomic number electronic configuration. Okay, now then what is the valence orbital, children? 2s2 2p4. 2s2 2p4. 4 plus 2 6 are there. More it should get stable means. So how many electrons required? How many electrons required? 2 electrons required, no? Then 6 losing easy, 2 gaining easy. 2 gaining only easy, no? Obviously that it will take from magnesium. Magnesium side, how many electrons are there? Only 2 electrons are there. Those 2 electrons will come and will join here. Okay, na? Then here 6 are there. Those 6 plus 2, how much? 8. And 6 plus 2, 8. Then becomes stable compound. And at once check it. Okay, na? Formation of magnesium oxide. Magnesium is 2 electrons losing, oxygen is 2 electrons are gaining. Understand? This is the way, children, to form ionic bond. Then now just we have seen, children, formation of ionic bond. Ionic bond means the changing of ions or transferring of ions. We'll call it like as ionic bond. Then what type of properties will have ionic compounds? Okay, now till now 3 examples we have taken, we have proved also. Then the physical properties we will see. Ionic compounds, what type of properties will have? Okay, physical properties. Ionic compound physical state, children. Physical state. Mostly, children, ionic compounds are crystals. What those are, children? Crystal in nature. Crystal in nature means what, children? In sodium, no sodium chloride. In what nature is available? Crystal in nature, like most of the ionic compounds are crystal in nature. The physical structure, if you see, means crystal in nature and solid at room temperature. What is that, children? Solids at room temperature. Solids at room temperature. Next, children, melting and boiling point. We'll see. MP means melting point, BP means boiling point. Okay, now? Then what type of melting points and boiling points will be in ionic compounds? Ionic compounds will have, children, high ionization, high melting points, high boiling points will be. Okay, now? The boiling points will be, children, high melting point and high boiling point will be. Okay, now? Metals and non-metal together is forming substance. So high melting point, high boiling point will be. Okay, now? Okay, high melting point, high boiling points will be. Next, children, electricity, children. Come to the one more property, electricity. When ionic compound, children, solid form, can't pass electricity. When ionic compounds, when is solid nature, it can't pass electricity. When ionic compounds is molten state, can pass electricity. Okay, now? Ionic compounds, when is there in molten stage, then ionic compounds all are good conductors of electricity. Why in solids not possible, children? And solid nature is there in between of ions, strongly packed together, there is no negligible space, due to negligible space, there is a not pass electricity, should not pass electricity and will not pass also. When in molten state, then possibility is there. Okay, that means what, children? Ionic compounds all are, when in molten state, good conductors of electricity. In molten state, good conductors. Okay, these are the some of the physical properties, children. What those are, children? Physical states, which we have completed in earlier examples, children. And formation of sodium chloride we have seen, and formation of magnesium chloride we have seen, and formation of magnesium oxide also we have seen in ionic compounds. Many of examples we have taken like as a ionic compounds. Okay, now? Then physical properties about we are learning now. Okay, now? Physical state. Physical state means what, children? Almost and all ionic compounds are crystal in nature is available and solids at room temperature. Okay, na? And strong nature will be solids at a room temperature. Then what melting points and boiling points will be the, children? Ionic compounds, mostly will be high melting point, high boiling point will be. Okay, no? High ionic compounds all are, children, high melting point, high boiling point will be. Okay, na? Electricity, children. That means electricity means what, children? And solids can pass electricity through them. Not possible, no? When the solid nature is not possible, no? That means, many of metals, many of solids we are telling, almost, and when solids nature is there, not possible to that much. When is molten stage, all ionic compounds can pass electricity through them. These are the properties of ionic compounds. This is the, children, in chemical bonding, ionic compound about brief explanation. What we have seen, children, what we have learned, ionic compounds definitions, ionic compounds features, formation of ionic compounds, and formation of examples, and properties of ionic compounds. Okay, na? I hope everyone understand. Thank you so much, children. I hope everyone understand this topic which we discussed, which we learned now, which we have taken examples. I think you all understand these all topics. Very, very important, children. And every year, no, one state syllabus, no, and one SSC exam paper will be there, no, physical science. There definitely one question will come from chemical bonding. Very, very important. Such important topic, no. Everyone should learn this topic, should listen these topics. Okay, na? One should go through on this topic. Okay, na? Thank you so much.